We have seen all possible scenarios of 1 1 and many 1. Now let's in this video see for the scenarios for onto and into. Okay, when f and g and gof. So as you can see, if g is into, then gof is into, because g into means g is from b to c. Okay, this is your g, this is your g, and this is your f. If g is into function, it means that uh, the range of g is a proper subset of c. So if g is into, then gof is into. Okay, so f can be onto or f can be into. I don't care. If g is into, then gof is into. Okay, what if when g is onto? When g is onto, then what is gof? So the two cases are when f is into and when f is onto. So let's look at the third case, when f is into and g is onto. F is into, then it means that there are some elements of b which will never come is in the input of g. As the input of g in the gof function, g is g of f of x. So there will be some elements that will not come here. Okay. Now, because g is onto, so is there possibility for gof to be into? Yes, because what if these elements that do not come as the range of f, what if these elements that are not in the range of f have a 1-to-1 relationship just for this subset? What if they have 1-to-1 relationship? So for these elements in your C, they don't have any pre-image other than this set. So maybe I can say that, okay, let's say this have a pre-image here also, and there's no such thing like this. I don't care. I am just saying that what if there is a set of elements in C that has a pre-image among these elements of B only, which is not in the range of F. In that case, your gof is into. Similarly, what if your gof can be onto also? You can think of a function in which f is into and g is onto and gof is onto. So how would you reason it? You would reason it in this way, that maybe the remaining elements that is in the range, you know, they are mapped to all the elements in C. Okay, and the elements that are out of the range, they are also mapped to within those elements only. Then it is onto. So you can't say, you can't say it can be into, or can be onto. Based on the given function, you will decide. Now let's look at this last, when f is onto and g is onto. Now look at this. When f is onto, it means all the elements of b is in the range of f. And when all the elements of b is in the range of f, means all of them will come as an input to g of gof. So g of fx here is range, and range is equal to codomain, range is equal to set b. And because g is also onto, so it means that, and it is covering all the elements of b, means your input to g is covering all the elements of b. It means, and g is onto, it means that the range of gof is also onto, because the range of gof is from a to c, and it will be all the elements of C. So when f is onto, g is onto, then gof is also onto. Okay. Should I explain it once more? This last one. Listen, in case of f, it is onto function. When f is onto, it means that the range of f is all the elements of B. And so in your function of GOF, in your GOF, what will go as an input to G, what are the elements that go as inputs to G are all the elements of P. And so basically, what is the range of GOF is equal to range of G only, and G is onto function. And so uh, the range of G is the whole set C. And so GOF is from A to C and range is C, so GOF is also on. Okay. Is there anything left about the composition of function? Okay, let's look at commutativity and commutativity, commuta- commutativity, commutativity and associativity. What is commutativity? Let's say you have two functions f and g, okay. Commutativity means that when you have two functions f and g, there's either GOF is possible or maybe fog is also possible. When GOF and fog both are possible, for any composition to be valid or to hold, what is it? If you have GOF, it means that what? First you will apply f and then you will apply g onto the output coming out from f. So to apply f means that for GOF to hold, the range of f should be the subset, should be at least subset of G, a domain of G, right? Similarly, for fog to hold, the range of G should at least be a subset of the domain of F. So if I am saying that, let's say F is from A to B and G is from B to C. Now in this case, GOF exists because the range of F is B, is a subset of B. Maybe if it is onto function, then it is set B itself, and the domain of G is B. So GOF is possible, but fog in this case is not possible because the range of G is a subset, proper subset, or maybe equal to the set C only, but the domain of F is set A. Okay, so we can't say if fog exists. Fog will only exist when A is a superset of C, right? Or A is equal to C. So let's say that F is from R to R, means real number to real number, and G is also from R to R, so that both exist. F is from R to R and G is also from R to R. And we are going to take expressions for these two functions. Let's say F is equal to 2x plus 3. And of course, because this is a straight line, so it's a function. And it's a 1 function, 1 and onto function. Similarly, let's say G is equal to, G of x is equal to, f of x is equal to 2x plus 3 and g of x is equal to x square. So it's a parabola from, means through the origin. So anyways, if this is the case, then what is GOF of x and what is fog of x? Try to find out GOF x and fog x. Then GOF x means that G of what? G of f of x, right? So it is equal to G of what? F of x is 2x plus 3. So G of 2x plus 3. And G of x is x square. So G of 2x plus 3 is 2x plus 3 square, which is equal to